Lesson 5, Solving Problems with Systems of Linear Equations. Inequalities. Example 1. A company makes two types of boats in different assembly lines. Aluminum fishing boats and fiberglass boats. When both assembly lines are running at full capacity, a maximum of 20 boats can be made in a day. The demand for fiberglass boats is greater than the demand for aluminum boats. So the company makes at least 5 more fiberglass boats than aluminum boats each day. So we have to make our system. So first let's let A equal aluminum and F equal fiberglass. So if we add A plus F, we know that there's a maximum of 20, so it can either be less than or equal to 20. So that's our first inequality. Now the second part says there has to be at least 5 more fiberglass boats than aluminum boats. So if you take fiberglass boats, which is more, and you subtract however many aluminum boats there are, we know that it's going to be greater than or equal to 5, because there's more fiberglass boats than aluminum boats by a difference of at least 5. So there's our two inequalities. So we are going to graph them. So first off, make your x-axis one of your boats, so let's call it aluminum. And our y-axis can be fiberglass. Okay, so we are going to graph our first line. So let's find our F and our A intercept. So if we find our F intercept, that means A has to equal 0. So 0 plus F is equal to 20. So F is equal to 20. So we will have a point at 0, 20. Our A intercept for our first line means that F equals 0. So A plus 0 is equal to 20. So we'll have a point at 20, 0. So both of our intercepts are 20. So let's label that. So let's go up by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Same with on the bottom. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I didn't have enough room. So because it's greater than or equal to, we can do a straight line. So draw your straight line. There. Okay. Now we're going to draw our second line. So we'll find our F. Oh, let's actually shade first. So we want it to be less than or equal to 20, and this is discrete, so we know it would be below. So I'm just going to leave this till the end. So you would shade lightly below. Let's do our second line. So for our F intercept, we will make A equal to 0. So F minus 0 is greater than or equal to 5. And remember, we're looking for our boundary line, so it's equal to 5, so F equals 5. So we will have a point at 0, 5. Right there. Now we have our A intercept, so F is equal to 0. So 0 minus A is equal to 5. So A would actually be at -5. And because we don't have that on a graph, we're going to just find a point. So let's choose a point at 10. So let's let A equal 10. So F minus 10 is equal to 15, plus 10 to both sides, so 5, is equal to 15. I got ahead of myself. So we will have a point at 10, 15. So 10, 15. And because it's greater than or equal to, it'll be a straight line. So we draw a straight line connecting the points. So there is our two lines. Now, this one, we want it to be greater than, so we want to shade above the line. So the area that overlaps is this little triangle between the two boats. And I'm going to show you mine that is actually drawn not. So here is our graph. So our shaded region, I just dotted the shaded region that overlapped so that you could see it. So this is our shaded region. So we want to choose a point that will work for our solution, and we want to verify it. So let's choose the point 4, 12, right there. So if we plug this into our equation, so 4 plus 12 is less than or equal to 20. 16 is in fact less than 20. And 12 minus 4 is greater than 5. 8 is greater than 5. So you could make 4 aluminum boats and 12 fiberglass. And anything else in the shaded region would also work. Example 2. A sloop is a sailboat with 2 sails, a mainsail and a jib. When the sail is fully out, it's said to be out 100%. When the winds are high, sailors often reel or pull in the sails to be less than their full capacity. Jim is sailing at a wind of 22 knots, so he wants no more than 80% of the mainsail out. Jim also wants more mainsail out than jib. So let's let M equal the mainsail and J equal the jib. So we want the mainsail to be less than or equal to 80%. And we also want the M to be greater than the jib, the main to be greater than the jib. So there's our two inequalities. We're going to make the x-axis the mainsail, and we'll make the y-axis the jib. So we're going to graph this. So first we'll do M equals 80. So that's just a straight line. So it's a straight line because it's greater than or equal to, so not broken. And we're going to label our x-axis by 10. So 10, 20, 30, 40, 50, 60, 70, 80. So we want to draw a straight line through 80 because all m's are 80. And we want it to be less than, so we would shade on this side. Now it's continuous because you can hit decimals here. You could have 75.5%, and that's fine. It will hit every single point in between. So this is a continuous question, so shade everything to the left. Now we're going to do M equals J. Now if you were to imagine M equals J is y equals mx plus b, it would be J equals something times x. Or y equals mx plus b. Our y is J. Our m is our x. We have a 1, a slope of 1, and no intercept. So we're going to start at 0 and 0. We're going to go up by 1s. Now this one is a broken line because it's just a greater than sign. So draw a broken line for this line. And we want it to be greater than, we want M to be greater than J. So let's choose a test point of 20, 10. So 20, 10 right there. So we know that our M is 20 and our J is 10. So 20 is greater than 10. And that's true, so we want to shade below. So our shaded region should be in this area. So your final graph should look like this. So we want to choose a point that would work. So I chose the point 40, 20. So 40 is less than or equal to 80, that's correct, and 40 is greater than 20, that's correct. So you could have the mainsail at 40% and the jib at 20%. And any other solution in the shaded region would work as well.